All right, let's take a look at the radicals unit. This one, basically you're multiplying conjugates. And as a reminder, conjugate is basically a term that is set up in a way that when you FOIL, the outer and the inner terms will cancel out. So you have your 3 plus radical 5 times 3 minus radical 5. You're going to end up with 2 of the middle terms canceling out. Number 24 through 29, basically you have your square roots, your cube roots, and your fourth roots. And this goes along with the way I taught this, where square root jail you can break out in groups of 2. Cube root jail requires groups of 3, and fourth root jail requires groups of 4, where only one member of each group actually makes it out. Number 25, I've sort of written this one out for you, I've expanded it. The cube root of a fraction can be rewritten as the cube root of the numerator divided by the cube root of the denominator. So here we have a to the 6th power is a times a times a times a times a times a, and b to the 9th power is 9 b's multiplied together, all divided by the cube root of -4 times -4 times -4. Now I chose to use -4 times -4 times -4 because it's already a trio. We could have written this as -2 times -2 times -2 times -2 times -2 times -2. We could have done that. It's really the same thing, except it's less work. And just remember that when you break these guys out, you group them in trios like this. And 2 don't make it, 1 makes it out. 2 don't make it, 1 make it out. Same thing here, same thing here, same thing here. All over 2 don't make it, 1 make it out. And as you can see, you just rewrite this in simplified form and there's your solution. Number 26, you want to combine like radicals. So here we're performing the sum of this cube root and this cube root. So I went ahead and wrote out the expanded form. Basically, we're writing out all the prime factors. So 2 times 3 times 4a's times 2b's. The cube root of 2 times 3 times 3 times 3 times 3 times these a's times these b's. Make sure you simplify the radicals carefully and combine like radicals. Number 27, pretty much the same thing as 26, except here we are subtracting. Also keep in mind that this is square root because there's no number in the index of the radical, which means it's a 2, square roots. Number 28, this is a combination of 26 and 27 where you'll be subtracting and adding. These are all square roots. Number 29, so here we have sort of the reverse of what I showed you with this one here. We took the cube root of a fraction and broke it up to the cube root of the numerator divided by the cube root of the denominator, whereas over here it's already split up into 2 square roots, and now we're putting it all under the same square root sign because we can simplify. And that makes our lives a lot easier. We can take 108 divided by 6. We can take x to the 5th, and we can cancel out one of these x's here. Y to the 8th divided by y to the 5th. We can cancel that as well. So as you can see, 108 divided by 6 is 18. X to the 5th divided by x to the invisible first. 5 minus 1 is 4. This leaves me x to the 4th. And y to the 8th divided by y to the 5th is y cubed. Now remember, this is still all under the radical, so you need to go through here, you need to simplify. Number 30. This expression is equivalent to which one of these multiple choice options? You need to multiply the numerator and denominator by the conjugate. Number 31, same problem, multiply by the conjugate. Same thing for number 32. Okay, number 33. When you have a rational in the denominator, it is not simplified. You must rationalize the denominator. So first thing we're going to do is simplify the radical. So as you can see, we have 3 over radical 3 times a times a times b. And since this is square root, the pair of a's can be simplified. One of them make it out. There we go. 3b remains within the radical. And now that we have this, we can go ahead and we can rationalize. So we only rationalize the part of the denominator that's under the radical. So we're going to multiply radical 3b both times the numerator and times the denominator. So when you multiply radical 3b times radical 3b, we end up with radical 3 times b times b. And this can be simplified. If you remember, you can pair these up. One of them make it out, one each. Okay, I'll let you finish this one up. Number 34. Now this one could be confusing. You have to remember that this entire denominator is under the radical sign, x plus 2. Therefore, we need to rationalize, which means multiply both the numerator and denominator by x plus 2. So we basically end up with this radical canceling this radical. We have 2x plus 4 times radical x plus 2 all over x plus 2. So my hint to you here is factor out your GCF and simplify. Number 35. Once again, multiply by the conjugate. This time everything is a variable. That's okay. Make sure when you multiply by the conjugate, you FOIL appropriately, and the numerator will distribute. So the x times the x and the x times radical x. Simplify at the end. If you can factor something out at the end, make sure you factor. Number 36 through 40. Okay, now we're taking a look at radical equations. So an equation has an equal sign. And if you remember, the trick behind these are to square the square root. Now, in algebra, whatever you do to the left side of an equation, you must do to the right side. So here we are squaring the left side and we're squaring the right side. So, first step, isolate the radical. The radical is already by itself. Second step, square both sides to undo the radical. So here we have 3x plus 16 because the square and the square root cancel each other out. On the right side we have x plus 2 squared, which is x plus 2 times x plus 2. Now I am emphasizing this because so many people make mistakes when they have a binomial squared, because they only do x squared plus 2 squared and they get x squared plus 4, which is wrong because you need to FOIL. And when you FOIL, you end up with this middle term. Okay? So I work this one all the way through. As you can see, here's your factor step, and your solution set is -4 and 3. Now your answer, your final answer is 3, because when you take -4 and you plug it back into the original equation, we end up with -12 plus 16 under the radical, which is radical 4, which is 2. Does 2 equal -2? No, it does not, and that's why we call -4 an extraneous root. Number 37, we're going to do this the same way. Isolate the radical, which it already is by itself, and square both sides. Number 38, same thing. Square both sides. Number 39, isolate the radical. Here, the radical is not by itself because we have 4 over here. Now, we could have subtracted 4 from both sides, but then we'd end up with a negative radical. So to take care of that, it's easier to just add radical 2x minus 5 to both sides. This totally cancels out. We're left with 4 equals 1 plus radical 2x minus 5. And we subtract 1 from both sides, and we end up with 3 equals radical 2x minus 5. And this is a lot more doable than, it's just an easier way to get to isolating the radical. Okay, and now you just go through and you square the left, you square the right, and you solve for x. Number 40, again, you're going to need to isolate the radical, subtract 11x from both sides. The minus 11x will go under the 7x because these are like terms. Those cancel out. 7x minus 11x is -4x. And now we have the radical isolated. Now, just because there's a trinomial under the radical doesn't make this more difficult. You're still squaring both sides. Okay, we'll square the left side and square the right side. And make sure you FOIL this binomial. Okay, number 50. Here we have a negative fractional exponent. Okay, without doing this problem for you, here are my 2 examples. So here's your negative exponent, which basically means reciprocate it and make the exponent positive. So we have 1 over x to the first power, which is just 1 over x. And when you have a fractional exponent, this really means it's a radical. So we'll rewrite this with the 2 right here is the index of the radical. This is the square root of y. And you could put the power outside of everything here, or you could put the power underneath the radical. They're both mean the same thing. And this 2 is not necessary, it's optional, because when there's no number in the index of the radical, you know it's square root. Number 51, the same thing. The only difference is that this is a binomial. You have a negative fractional exponent, so make sure you reciprocate the whole thing and then rewrite it as a radical. All right, finally number 52. Number 52, we have the 4th root, which I want you to rewrite as a fractional exponent. So as you can see, it's 1/4. Distribute the powers. And finally, so here, I'll do that for you. You have 16 to the 1/4. X to the, now 2 times 1/4 is 2/4. And y to the 7th, the 7 times 1/4 is 7/4. So just make sure you remember to simplify this 16 to the 1/4 is really the 4th root of 16. And x to the 2/4, you can reduce this fraction here.